Let's go ahead and finish up this surface area, lateral area, and volume chapter, shall we? I guess two chapters. So first we're going to start with pyramids, and that would be section 5 in chapter 12, or section 5 in chapter 12 and section 2 in chapter 13. So here are the formulas. We have the lateral area, which is 1/2 L. Now remember that L is the slant height. So when you have a pyramid, now granted this is going to be drawn absolutely horribly, but when you have a pyramid, you have, I'm sorry about that line, that's kind of bad. You have a height of the side of the triangle. That is what your slant height would be. So going up the side. P is still perimeter, and remember this is perimeter of the base. All right, and then surface area. So of course it's taking your lateral area and then adding the area of the base to it. And then for volume, we take 1/3 area of the base and multiply by the height. Now when we're talking about height, we're talking about altitude. Okay, so straight down the center, it goes down, so down the center of the pyramid. I left the P out. There we go, the pyramid. Okay, so the height is in the inside, and what happens is, and I'll write this up here, you need to write this, the height will be in the middle, I guess I can say in the center of the base. And that's helpful when we have to use an apothem because we know where the apothem should come from. If it's a square, then this distance is half of the square. So it makes it really helpful once you get that height drawn in. A pyramid, so the base is always a regular hexagon, and it's for regular pyramids, which would make sense to have a regular polygon, not hexagon. I don't know why I said that, I'm sorry. The lateral faces, so lateral means everything except for the bases. They all come to a point up here, and that would be your vertex, and then we have each side that are triangles. So in this case we have 4 triangles on the side. The altitude, again, that segment that's perpendicular, this is also the height. So when you see that in the formula, know that those two are the same thing, straight down. And then the slant height is the height of a lateral face. So they call it slant height because it's just that. It makes a slant. And then what you'll notice happens is the height, the slant height, and the base together make a right triangle. So of course you'll be expecting either trig or the Pythagorean theorem to kind of work its way back into this chapter as well. So to save some time, I worked some of these out already. So we've got perimeter of the base, slant height, and the area of the base. And here are your 3 formulas that you need. And here's an example. So we've got all of our information here. So when we first start with finding the perimeter, well, we have 2 of the sides that are 6 and 2 of the sides that are 7. So the perimeter of the whole thing is 26, so we're just adding all of those sides together. And there's only one base, so this one's a little bit easier than the prisms. The slant height, that would be out here, the 8, this dashed line here. And then the height would be the altitude, which is 5, so that's one that is straight down. Okay, and then we've got all of the information needed to do all 3 formulas. Starting with the lateral area, it's 1/2 the slant height, which is 8, multiplied by the perimeter, which is 26. So we get 104 square units or units squared, either one. The area of the base, now we need that for surface area. And what do you notice about lateral area and surface area? Well, the lateral area is this formula right here. So all you're doing for surface area is adding on the area of the base. So if the surface area is 104 and the area of the base, remember length times width, is 42, then all we have to do is add that to our lateral area to get 146. And then plug in all your information for volume as well, 1/3, and we've got 42 is the area of the base, which we got from up here. And then we have 5, which is our height. Remember, height is your altitude. And then we have cubed. Our units are cubed for volume. All area is always squared. You know, square units, it's area. Okay? Any type of area is always squared, where volume is cubed. So that's it for pyramids, really. We'll do examples in class, and now we're moving on to cones. And cones basically are right pyramids, and they just have a circular base, where in a pyramid you have a regular polygon. So with the circular base, what happens here is when you draw the height in, it's the center of the circle still, and then you have your radius, and that makes it really helpful for finding the area of the circle, and also you've got the right triangle happening again. Now all of these letters, the L still is slant height, that has not changed. And then you know R is radius. And then we have H, which is still height, and remember that that also means altitude, so straight down the center of the cone. And of course, written down here, knowing that those two are the same thing and that all three of these will make a right triangle together. So again, Pythagorean theorem, or maybe some trig we'll have to bring into this to finish up what we need. So for the cone, find the lateral area, the surface area, and the volume. Well, first of all, the lateral area for a cone is pi r L. So we have the radius, this is r, this is our h, this one out here is our L. Now we don't have the slant height, but it's a right triangle. So you can do your a squared plus b squared equals c squared. Plug in your information, so 8 squared plus 6 squared equals c squared. 64 plus 36 is c squared, so you end up with 100, which leaves you with 10. So your slant height over here is 10. So now as we go to plug that into our lateral area formula, which is pi r L, our lateral area would be pi times the radius, which is 6, times slant height, which is 10, which would give us a total of 60 pi centimeters, and then remember area is squared. You can leave the pi in or multiply it, it doesn't make a difference at all. Now for the surface area, our surface area formula is to take our lateral area, which is pi r L, and add to that the area of the base, which is pi r squared. So we already have the lateral area here, which is 60 pi. And now we need to add to that pi times the radius squared. Well, we have the radius, which is 6, and we're just going to square that. So we end up with 60 pi plus 36 pi. You can add those two together because they both have pi in them, so 96, you end up with 96 pi centimeters, and again squared because it's area. Now we're looking for volume. Our volume formula, again, is 1/3 pi r squared h. So it's the area of the base multiplied by the height, and then 1/3 of that. So 1/3 pi r squared we got earlier, this 36 pi, so we can go ahead and do this, 36 pi, and then multiply by the height, which is 8. If we take 1/3 of 36, we get 12 pi, multiply by 8, and we end up with 96 pi. And now, because it's volume, we do centimeters cubed. See, it's not so bad, right? Pretty easy. And that's it for our cones. And lastly, our last little bit is the spheres. And now with this one, spheres are just like circles where they have a center point and they have points that are all the same distance all the way around. The only difference with a sphere is that now it is 3D. So sphere is 3D where circle is 2-dimensional. And as I was saying in some of the classes, and I'll try and find a video, but a sphere is just a circle that rotates. It's one that rotates forward, sideways, and then on both diagonals, and it ends up making the whole sphere. There are some special segments and lines that are really important for you to know inside a sphere, and things that are a little bit different. So a radius would be a segment whose endpoints are on the center, so here, and it goes to the sphere, right? And then of course we have a chord, which goes from side to side. Diameter, so a chord that goes through the center, and then tangent. So we think these are all pretty much the same. They look pretty much the same. It's a little bit different with a chord. What you'll notice is it actually kind of looks more like a circle, and I'll try and show you an example of that when you come into the class next time I have you. So for surface area and volume of a sphere, remember there is no lateral area. Okay, because lateral area is everything except for the base, but we don't have bases in a sphere, so we don't have any lateral area. We just have our surface area, which is 4 pi r squared, and if you ask me, I'll help you remember why it is 4. It's actually kind of cool. It was something I was just saying in the last slide, actually. Then we have the volume, which is 4/3 pi r cubed. So for this sphere here, if we wanted the surface area and the volume, we would start with plugging in our information. We have 4 pi, and then the radius, which is 12, and then square the 12. So we end up with 144 times 4 times pi. So we end up with 576 pi, and then it's centimeters squared because it's area. Now if we go to do our volume, 4/3 pi r, now this time it's cubed, so pi r cubed. So we end up with 2304 pi, and now centimeters cubed, and that would be our volume. Be really careful that if you see that the diameter is 12, so if the diameter is 12, remember that you're taking the radius, so half of that. Okay, so be really careful that you aren't automatically jumping into and just plugging in the information. Or another thing you may see, and this can happen anytime you have a circle, is maybe they'll give you that their circumference is 20 pi. Well, what is their circumference really? It's the diameter times pi, which means that the, I'm sorry, I didn't mean to do that one. That would mean that the diameter is 10, which would make the radius 5. And then you can plug it into your information. So be careful with that kind of stuff. Same with if they told you that the area, which we know is pi r squared, if we knew that the pi r squared was equal to 36 pi. Well, if the area is 36 pi, and we know that area is pi r squared, well, what would you square to get 36? 6. So we can still work forward and backwards depending on where we're starting from without any kind of a problem at all. All right, then with the spheres, of course, we have hemisphere, and all that is half of a sphere. That's it, just half of it. So for the surface area and the volume, use the sphere, So use the sphere formulas, but when you finish, divide by 2. That's it. That's all you have to do. So if we come back here real quick, if we only wanted the surface area of a hemisphere, we would take this and divide it by 2. Same with the volume, divide it by 2. So you're going to use all the same formulas, just cut it in half. So it just depends on what shape you have. Okay? So that's it. This is it for the new stuff. We're done for new stuff for the year. And now it's just time to dance with these creepy disco balls I found.